Welcome to my channel. Today we are going to discuss about the multiple choice question and answer from the topic reflection and transmission coefficient. Okay, reflection coefficient and transmission coefficient from the subject transmission lines and RF system or transmission lines and waveguides. Okay, so this is for both 2013 regulation as well as 2017 regulation. Okay, the first question you see, the voltage reflection coefficient can be defined as dash. Okay, so in order to measure how much reflections available in a transmission line, we are using the parameter, it is called as a voltage reflection coefficient. So the voltage reflection coefficient can be defined as ratio of amplitude of reflected voltage wave to the transmitted voltage wave, ratio of amplitude of reflected voltage to the incident voltage, ratio of load impedance to the characteristics impedance, none of the mentioned. The reflection coefficient is nothing but it's a ratio of amplitude of reflected voltage to the incident voltage. It is called as a reflection coefficient. Okay, so it is indicated by K or sometime it is indicated by capital R. It's the ratio of reflected voltage divided by incident voltage. Okay, then the next one, the reflection coefficient lies in the range. Okay, what is the range of the reflection coefficient? The reflection coefficient is in between 0 to 1. Okay, the minimum value is 0, the maximum value is 1. So if the reflection coefficient is unity, means there is no transmission. If the reflection coefficient value equal to 1 means, so the full signal is reflected back. That is the meaning. If reflection coefficient is 0 means full transmission has occurred in the particular transmission line. Then the next one, the reflection coefficient of a perfectly matched transmission line is dash. So perfectly matched transmission line means, so the signal is transmitted, the 100% signal is transmitted from the transmitter to receiver. So there is no reflections occurring from receiver to transmitter. That is the perfectly matched transmission line. So in that, what is the reflection coefficient? The reflection coefficient, it should be 0. Okay, for a perfect transmission line, the reflection coefficient, it should be 0. Then the next thing, which one is correct for reflection coefficient? Okay, reflection coefficient formula is given. So the reflection coefficient K equal to, it's the ratio of ZR minus Z0 divided by ZR plus Z0, where ZR is the receiving end impedance. Okay, received impedance or load impedance. Z0 is the characteristics impedance. Okay, you just remember this reflection coefficient formula, K equal to ZR minus Z0 by ZR plus Z0. The next one, the measure of mismatch between the load and the transmission line is known as dash. So the mismatch between load and the transmission line is indicated by the reflection coefficient. The mismatch between load and transmission line is indicated by the reflection coefficient. Then what is the value of reflection coefficient if the transmission line is terminated by its characteristics impedance? So if the transmission line is terminated by the characteristics impedance Z0 means, at the time, what is the reflection coefficient? The reflection coefficient value, it is 0. Okay, since you see this is the reflection coefficient formula. So here what is the condition given? The load impedance, that is the ZR value equal to Z0. So you just substitute, if ZR is equal to Z0, what is the numerator? It is 0. So 0 divided by anything, it is 0. So if the transmission line is terminated by the characteristics impedance, the reflection coefficient value is 0. So reflection coefficient value 0 means, what is the meaning? It's a matched transmission line. Okay, then the next thing, when the ratio of load voltage to input voltage is 5, the ratio of characteristics impedance to input impedance is dash. So for a transmission line, the ratio of load voltage to input voltage is same as the ratio of characteristics impedance to input impedance. So that's why the ratio of characteristics impedance to input impedance is also 5. Okay, so this is the this condition is obeyed for any transmission line. The next thing, the reflection coefficient of a wave with transmission coefficient 0.35 is dash. Okay, so here the transmission coefficient is given. The question is that we have to find the reflection coefficient. So the reflection coefficient and the transmission coefficient both are inverse. Okay, that is the the addition of reflection coefficient, the transmission coefficient value, it is always 1. The reverse of reflection coefficient is a transmission coefficient. Okay, so the addition of reflection coefficient R, transmission coefficient T is always 1. So here the transmission coefficient is 0.35. So therefore the reflection coefficient is equal to 1 minus 0.35. So the answer is 0.65. So this is the answer. Okay, similar to reflection coefficient, there is a transmission coefficient is also there in a transmission line. The next one, the incident wave amplitude is 24 volt. The reflected wave amplitude, find the reflected wave amplitude if the reflection coefficient is 0.6. Okay, this is a 2 more problem. So what are the data given? You see, incident wave amplitude 24 volt. Reflected wave amplitude we have to find out. Reflection coefficient is given as 0.6. What is the relation between these things? The reflection coefficient is equal to ratio of reflected voltage divided by incident voltage. Here the incident voltage is given, K is given. We have to find out reflected voltage. So from that the reflected voltage is equal to K into EI. So 0.6 into 24. So the answer is 14.4. This is the answer. The next thing, the reflection coefficient of a transmission line having the characteristics and the load impedance is 30 and 50 ohm respectively is dash. So here we have to find out the reflection coefficient. The characteristics impedance means Z0. Z0 is given as 30 and the load impedance is 50. So we have to find out the reflection coefficient. So this is a very important 2 more problem. So here ZR given, Z0 given. Okay, load impedance is ZR. Characteristics impedance is this 30. So you just substitute in the formula. So K equal to ZR minus Z0 by ZR plus Z0. Okay. Or instead of ZR, we may put ZL also. Okay, load impedance. So 50 minus 30 divided by 50 plus 30. So we will get the answer as 0.25. So 0.25, this 1 by 4 is the answer. Then the next question, calculate transmission coefficient when incident and transmitted amplitudes are 10 and 7 respectively. So the transmission coefficient is nothing but it's the ratio of transmitted amplitude to the incident amplitude. So 10, so the transmitted amplitude is 7, incident amplitude is 10. So 7 divided by 10, it's a 0.7. This is the transmission coefficient. Transmission coefficient means it's the ratio of transmitted amplitude divided by incident amplitude. Okay. The next thing, in matched line, the transmission coefficient is dash. Okay. For a matched line, the transmission coefficient is 1. Okay. Already you know, for a matched line, the reflection coefficient, it should be 0. Okay, that is a matched line means the transmission is occurring in only one direction from transmitter to receiver. Okay, the full wave is transmitted from transmitter to receiver. No wave will come back to transmitter from the receiver. It is a matched transmission line. So for a matched transmission line, the reflection coefficient, it should be 0. Transmission coefficient, it should be 1. Then the next thing, the transmitted power in a transmission line, when the reflection coefficient and the incident power or 0.6, 24 volt respectively is dash. Okay, so here the question is transmitted power. We have to calculate. So what are the two given data? Reflection coefficient is 0.6 and incident power is 24 volt. Okay, so what is the relation between the transmitted power, reflection coefficient and incident power? Means the transmitted power is equal to 1 minus R squared into P incident power. Here R is a reflection coefficient. PINC is a incident power. So R value here is 0.6. Incident power is 24 volt. So you just substitute. We will get the answer is 15.36. Okay, so 15.36 watts is the answer. The next one, the reflection coefficient of a short circuit transmission line is -1. It's a true or false? Okay, it's a true. So for a short circuit transmission line, what is mean by short circuit transmission line? For a short circuit transmission line, the load impedance, okay, the load impedance is at R is equal to 0. Under short circuited condition, the load impedance is equal to 0. So if you are substituting ZR equal to 0 in our reflection coefficient formula, we will get minus Z0 by Z0, so -1. So for a short circuit transmission line, the reflection coefficient is -1. Okay, it's a true only. Then the next thing, when reflection takes place in transmission line, load impedance is equal to the characteristics impedance. Load impedance is not equal to the characteristics impedance. The reflection takes place whenever the load impedance is not equal to the characteristics impedance. That means ZL is not equal to Z0 or ZR is not equal to Z0, means at that time reflection takes place in a transmission line. The next thing, dash is defined as the ratio of voltage at the sending end to the current at the same end. So dash is defined as the ratio of voltage at the sending end and current at the same end. It is said to be input impedance. Input impedance of the transmission line is nothing but voltage at the sending end divided by current flowing in the sending end. Vs divided by Is, it is called as a input impedance. Okay. Then the next thing, what is the expression for input impedance of a transmission line? So you just remember the answer. The input impedance of transmission line is Zs equal to Z0 into Zr cos h eta L plus Z0 sin h eta L by Z0 cos h eta L plus Zr sin h eta L. It's a correct. Similarly, Z is equal to Z0 into Zr plus Z0 tan h eta L by Z0 plus Zr tan h beta L. This is also correct. And this one is wrong. Okay, so both A and B is the answer. Okay, both A and B is the answer. This two thing is the formula for the input impedance of transmission line in terms of characteristics impedance, load impedance and propagation constant eta. The next thing, dash is defined as the ratio of voltage at the sending end to the current at the receiving end. Okay, voltage at the sending end and the current at the receiving end, IR, Vs divided by IR. It is said to be the transfer impedance. Okay, transfer impedance of the transmission line. The next thing, what is the expression for transfer impedance of the transmission line? So the transfer impedance formula is that ZT. Okay, transfer impedance is equal to Zr cos h eta L plus Z0 sin h eta L. This is the formula for the transfer impedance. Okay, the above thing is not a transfer impedance formula. The next one, if the transmission, if the line is terminated with characteristics impedance, then the input impedance is equal to the characteristics impedance. Is that true or false? Yes, true. Okay, if the line is terminated with the characteristics impedance, the input impedance is Z0 is always equal to the characteristics impedance. Okay, input impedance is always equal to the characteristics impedance. That is equal to Z0. Okay, so these are all the some of the questions from the reflection coefficient, transmission coefficient, input impedance and transfer impedance of the transmission line. Okay, so thanks for watching my channel, and please subscribe my channel for more videos and share this video to your friends also. If you want to learn the remaining MCQ questions for the transmission line and signals and system MCQs, then DSP, principles of DSP MCQ, electronic circuits to MCQ, then circuit analysis MCQ. In my channel there is a separate playlist is created for each subject. You go and learn, or otherwise I will give link in the description box, you can see. Okay, so thank you, we will meet in the next video.